Hey guys, welcome back. Yesterday we finished talking about Copeland's method, which is kind of a variant of the Condorcet method, where we look at the one-on-one matchups. And what we're going to look at today is we're going to look at the problems or what's wrong with Copeland's method. So just like any of the other voting methods that we've looked at, there's usually a problem with all of these voting methods that we're looking at. So there's going to be a problem with Copeland's method as well. Now, Copeland's method is a really good method if you compare it against the fairness criterion that we've talked about so far, such as the majority criterion, which right here, right, so our majority criterion. If somebody has a majority of first place votes, they are automatically going to end up being the Copeland winner, as they will win every single one-on-one matchup. It also satisfies the Condorcet criterion, so if there is a Condorcet winner, they will also be the Copeland winner. And then the monotonicity criterion is also satisfied. So in other words, Copeland's method won't violate the majority criterion, the monotonicity criterion, or the Condorcet criterion. So it seems like this is a really good method, but there is a fourth fairness criterion, which we're going to see today, and we'll see why Copeland's is not exactly the perfect method that we think it is. Okay, so let's look at example 11. We have a committee that's deciding on how to award a scholarship to one of 4 students, and they are going to use Copeland's method to determine that winner. All right, so we're going to make all of the one-on-one comparisons. So I've got them all set up here, A, B, A, C, D, so forth and so on. And we're going to go and look at who wins in these one-on-one matchups. I'll do the first one with you, and then I will fast forward through the rest, so you can pause if you would like, get your own results, and make sure that you are doing it correctly here. Okay, so for the first one, we're doing A versus B. So if I'm looking at A versus B in this first column, A is higher, so A is going to get these 5 votes. A is also higher here in the second column, so they'll get another 5 votes. And then A loses in the third and fourth column. So A is going to get 10 votes, and since there's a total of 20, we know that B will get the other 10 votes. So it's a 10 to 10 tie, which means A and B each get half a point. Okay, then I would move on to the next matchup and do the same thing. All right, so if you want to pause your video and get those tallies on your own, see how you do, go right ahead. All right, welcome back. So I've got the results tallied up over here. I went ahead and assigned points for each one-on-one comparison. So if I go and I tally them up, I'm looking at A here. A's got 1.5 points. I'll just put a 1.5 there. B is going to have 1.5 points as well. C will end up with 2 total points, and D will have 1 point, which means C wins Copeland's. Right? C was Carlos, so Carlos would get the scholarship. All right, so what's wrong? Well, what's wrong is about to happen here. So let's say after they do the vote, the committee discovers that Dimitri was not eligible for the scholarship in the first place, so no one should have been able to vote for him. So he should have never appeared on the preference ballots in the first place. Okay, and if I'm looking at the results of our first vote when we tallied everything up, Dimitri only got 1 point. He was a last place finisher in the scholarship contention anyways, so really eliminating him from the ballot shouldn't do anything. It shouldn't affect Carlos being the winner. All right, so Dimitri is what we call irrelevant. All right, it sounds mean, but he's irrelevant because in the first round or the first selection that we analyzed, he was not a winner. He was a last place finisher, so he was what we considered irrelevant, and what we're doing is we are removing an irrelevant choice from the ballot. And it should not affect the outcome, not if it's fair. Okay, so we're going to take a look at our ballot without Dimitri. Right, so here I have my preference ballots again. We got rid of Dimitri on all of them, and we're going to go back through and we're going to tally up the one-on-one comparisons here, the one-on-one matchups, and see what happens with the vote when Dimitri is no longer in there. Right. Again, I'll do the first one, and then you guys can do the next 2. So let's do A, B, right? So A is higher than B, so A will get those 5. A will get these 5, and then it loses in the next one. So we got another 10 to 10 here, right? So we would say A and B get a half point. All right, so you guys do the next two, see how you do. All right, guys, so I got it all cleared up here. So these are the tallies that I came up with. Just check your own results, see how you did. And then I assign my points over here. So tallying them up, it looks like A got 1.5 points, B got 0.5 points, and C got 1 point, and which would mean that A wins, right? All of a sudden Anna is the winner when Dimitri was eliminated from that initial ballot. Okay, so Anna becomes the winner even though an irrelevant choice was removed from the preference schedule. And this doesn't seem like it should have happened. It doesn't seem fair that Carlos lost out on the scholarship because we removed someone who shouldn't have been there in the first place. Okay, so this actually leads us to our fourth fairness criterion, and it's called the independence of irrelevant alternatives criterion. Okay, so remember that word irrelevant. Simply put, it means that if there is a non-winning choice that's removed from the ballot, it should not have an impact on the winner of the election. Okay, so that's the easy way to remember that situation, is if there is somebody who is a loser in an election and you remove them from the ballot, it should have no impact on who the winner is. All right, so just again, talking more about Copeland's method, one of the other things that could arise with Copeland's method besides violating this this particular fairness criterion is that it's fairly easy for Copeland's method to end in a tie, right? So after you tally up all the points, you could easily get several choices having the same number of points in the end. So usually when Copeland's method is used, it's used as part of a multi-stage voting system, so where they will do Copeland's method first, and then they'll take all of the people who tied for first, or all of the candidates who tied for first, and then use a separate voting system after that. So you do Copeland's first and then maybe an instant runoff, or maybe Copeland's first and then a plurality, or something of that nature to stack onto Copeland's. So while Copeland's is really good at not violating 3 of the 4 fairness criterion, it is really bad at resulting in ties at the end, so you usually have to supplement it with something else. Okay? So we've talked about several different voting methods, and every time we do, I always tell you there's something wrong with it, and we're looking, and you're probably thinking, well, is there a fair method that doesn't violate any of these fairness criterion that we've talked about so far? And as it turns out, there is no fair voting system. Every single voting system, every single method of voting that has ever been introduced in our history has been found to violate one of the 4 fairness criterion that I have stated for you guys throughout these lessons. All right, and there was a guy who actually mathematically proved that there will never be a voting system that is ever fair. There is no way to not violate all of the fairness criteria that we have discussed. So this guy, Kenneth Arrow, proved this back in 1949, and it led us to his impossibility theorem, which states that it is not possible for a voting method to satisfy every fairness criterion. It's just never going to happen. So whatever voting method you decide to use, right, you will know that it has a possibility of doing something that may be considered to be unfair. All right, so you anticipate that, and you look at your situation and you try and choose the one that you think is going to work best for your situation. All right. One more little example here, just to show you one of the scenarios that could happen, just to demonstrate how difficult voting can be. Consider this election down here. And let's say we do a Condorcet style vote here where we look at the one-on-one matchups. And if we analyze this, we'll see that 10 people prefer A to B, 10 people prefer B to C, and 10 people prefer C to A. And what this election illustrates is one of the paradoxes known as Condorcet's voting paradox. And at any point in this election, 2/3 of the voters would always prefer somebody else, right? There's no way to get an overall preference from this particular kind of ballot, right? It's very difficult to find a group consensus when the results fall the way they did in that particular election. All right, so that particular scenario is what's called the Condorcet voting paradox, and it just demonstrates how voting preferences are not transitive. So like if A prefers B and B prefers C, it does not mean that A is going to be preferred over C. All right, so that transitive property just doesn't work in voting. All right. So enough about that. That's where we're going to stop our lesson for today. So we got a couple more examples of that Copeland's method, and we really picked apart Copeland's method and all the things that can go wrong with it. So that's it for today's lesson. Have a great day.